altitude, it is the arc of vertical circle or the angle at center of Earth contained between plane of rational horizon and the center of the body. True zenith distance. It is arc of vertical circle through the body contained between zenith or also the principal vertical circle and center of the body, or in other words, it is the distance of body from zenith. Sum of true altitude plus zenith distance will always be 90 degree for any body. Azimuth. It is the arc of rational horizon or angle at the zenith contained between observer's meridian and the vertical circle through the body measured eastwards from north. Amplitude. It is the arc of rational horizon or the angle at zenith contained between prime vertical and vertical circle through the body when it is on rational horizon, that is at the time of theoretical rising or setting, measured north or south from the observer's east or west point, expressed as east 20 degrees south or west 10 degrees north. So guys, now let's look into how we obtain true altitude from sextant altitude and what are the components including in it. So let's see. You can see Earth and an observer standing on the surface of Earth and center of Earth as mentioned in the diagram. So now let's see. This will be our rational horizon with respect to the observer standing on the surface of Earth. The rational horizon will be changing with respect to the position where the observer will be standing. And this will be visible horizon, that is under direct line of sight of the observer. That is what you see at sea. And next horizon is our sensible horizon, which is parallel to our rational horizon through observer's eye level. All these three horizons we already discussed in previous videos. I am just reminding it again. Now, as you know from the diagram, this height will be your observer height. This has a significance. I will talk about it in further. Now we have a celestial body, as you can see, and this celestial body is on a vertical circle. As we know, vertical circle, that is passing through the celestial body. Now you can say this is vertical circle and this line, that is from center of Earth passing through the observer, meeting the celestial sphere at a point, and that point is called as zenith of your observer. So that is the definition for zenith. It's a line from center of Earth passing through the observer where it meets your celestial sphere. That is called as your zenith. Now this is the line of sight of observer to the celestial body, and this will be from center of Earth to celestial body. Now let's see what are each terms. This is our true altitude and this is our true zenith distance. As we discussed earlier, what is true altitude and true zenith distance? True altitude is arc of vertical circle or angle at center of Earth contained between your rational horizon and line joining from center of Earth to celestial body. And for true zenith distance, it is arc of vertical circle contained between zenith, line joining, or this is also called as your principal vertical circle, that is from north to south of your observer, and the line joining from center of Earth to the celestial body. So now, what is our sextant altitude? You can see in the diagram, this one is your sextant altitude. Again, you can see on ship, we used to take the side of the celestial body and we used to shoot it down to the horizon. So this is the horizon that you see out at sea, that's our visible horizon. So this will be your sextant altitude. And in this case, we are just considering, or let's assume sextant altitude, and how we obtain observer altitude is sextant altitude plus minus index error depending upon honor of arc. That index error is always an instrumental error. So if there is no instrumental error, we can say sextant altitude is same as your observer altitude. So let's say this observer altitude. Next factor is dip. So what is dip? Dip will be your arc of vertical circle contained between your sensible horizon and visible horizon. That is called as your dip. That is due to your observer's height. That is function of height. larger the observer height, larger the dip will be. That is obtained for your nautical almanac table initial pages. Next thing, as we know, from observed altitude, if we subtract dip, what we get is this portion, and this portion that is contained between your sensible horizon and the line joining observer eye to celestial body is nothing but it's called as your apparent altitude. So you can see now apparent altitude is this one, this angle, and now we have one more angle that is at this celestial body. What is that? This angle. This angle is called as your parallax. That is the angle at the celestial body contained between line joining observer to celestial body and line joining from center of earth to celestial body. That is known as your parallax. Now if you consider observer eye, sensible horizon and celestial body, this part, you can say this angle is an exterior angle to this triangle. This triangle, this is an exterior angle. As we know, exterior angle will be the sum of interior opposite angles. That means this parallax plus apparent altitude will give you this angle. So in this diagram, as we know, sensible horizon is parallel to rational horizon, and this line from center of earth to celestial body is cutting these two parallel lines. So we can say this angle true altitude and this angle are corresponding angles. So since this is true altitude, we can say this angle as also true altitude. So now we need to find true altitude. That is the basic thing what we need to find. So to find true altitude, we can say from this triangle, this is an exterior angle, true altitude, that is sum of two opposite interior angles, that is apparent altitude plus parallax will give you true altitude. But there are some other factors also considering. Those are semi-diameter and refraction that we will discuss. So we can conclude now. From sextant altitude to true altitude, how we get true is, we know sextant altitude plus minus index error will give you observed altitude, and if you don't have any index error, then we can say observed altitude is equal to sextant altitude. Next thing, observed altitude minus dip, that is due to height of observer, will give you apparent altitude, that is visible from your diagram. Your observed altitude minus your dip will give you apparent altitude between sensible horizon and line joining observer to celestial body. Next thing, from apparent altitude, how we get into our true altitude. So we can say apparent altitude plus minus semi-diameter, that is SD, plus parallax minus refraction will give you true altitude. In the previous one, we just said it is the factor, true altitude is just the sum of apparent altitude plus parallax. There are some other factors like semi-diameter and refraction that won't apply for every celestial bodies, but for some, yes, it applies. Like semi-diameter applies for sun and moon and not for stars and planets, and parallax applies mostly for all celestial bodies. So now we can say this ST, parallax and refraction, also called as total correction, this can be obtained from almanac initial first pages. So this parallax correction is always added, as you can see, as I have written SD, I have written plus minus, that depends on upper or lower place in which you are taking the bearing. Like sun, if you are taking upper limb or lower limb, it is what it depends, plus minus. And this parallax is always added and refraction is always subtracted. Now let's see into some important notes. As we say, parallax is a function of true altitude, higher celestial body, lesser parallax. As you can see in the diagram, since this is parallax, the way the celestial body moves ahead or farther from observer, the parallax will be getting smaller and smaller. That means higher the altitude, lesser parallax. Next point, SD. SD correction is always to center of celestial body. For sun, one value, that is for 3 days. Since I said if you are taking for such a large object like sun, we will be taking either upper limb or lower limb. So we apply the correction plus or minus depending upon upper limb or lower limb to get to our SD correction. So now for Sun we have one value for 3 days, and for Moon we have 3 values for 3 days. That means we have one value for each day, and this is also found in Nautical Almanac daily pages bottom. If you can check into it, you can easily recognize them. It's written S.D, that is semi-diameter, and for Moon and Sun separately it's written there. Next thing, one important thing, there is no semi-diameters for stars and planets, since they're farthest from Earth and you don't have such a big visibility of them. You will be having a pointed, so there is no SD for stars and planets. Next thing is refraction. Due to varying density at atmospheric layers, the refraction happens more denser at surface. As you know, as we go from surface of Earth to higher, the density of atmosphere is decreasing, and the ray of light, since it's coming from CB, it will be coming from rarer media to denser medium, and it's continuously refracted before reaching the observer. That is what is called as refraction, and refraction is always subtracted from your apparent altitude. It's always a negative correction. And also larger apparent altitude gives you larger refraction and vice versa. So guys, I hope you guys understood this video. We will see with more types of video in further.